So this short video, again about LabVIEW. Why I do this second video? Because I worked with LabVIEW for longer than 20 years, and I love this language. It is very easy to learn, and it is a lot of fun to work with it and to design especially if you work with in engineering and tests in research. LabVIEW is just a must. You have to use it, and you have to understand it. And as I said, yeah, I recommend you to buy a disk with LabVIEW. In Bangkok, there are shops who can sell you a disk with LabVIEW. Of course, it is not legal disk, but anyway, to learn the language, it is enough. It is enough. So it has a lot of advantages and easy to learn. So how it works? It works with data acquisition. Data acquisition, it is like you have some devices like sensors. With the sensors measure pressure or temperature or some pressure, temperature, whatever signal, the situation of viscosity or whatever. It's quite many sensors. You can connect to the data acquisition board, special device that transform the signals to binary code. Then computer works with binary code. Okay, then data acquisition, it is work with mostly experiments and tests, but also it can do some calculations, and but again, the highest, the best, it works for experimental data, for test, especially if you're like testing an engine or whatever machine. Then you have a lot of signals, and you can connect to your computer maybe sometimes 16 channels or with signals, or even more, and then you work with the signals. You are getting signals output for control the devices or machines or engines, and then it is really very useful language. Okay, how to translate it is LabVIEW. It is Laboratory Virtual Instrument Engineering Workbench. It is based on graphical programming language G, and then it is easy to learn, and it relies on graphical symbols and some diagrams instead of text. It is writing a text. So you have data flow, which data going in as a signal, and then you get also the output. Output can be to interface, or output can be as signals to control your equipment. So this is how normally interface looks like. So you can make any picture on it, and then you see some for input or for out or for data, and switches on off. You can design quite nice looking interface, or the so-called front panel. And then okay, but as I said, I recommend you to install this program if you want to work in research and tests and industry. Then it will be helpful. So you can install it, and you can create new virtual instrument for you, or open existing virtual instrument, etc. And also a lot of libraries, a lot of that you can get from internet, and examples. So it's easy to work with it. Okay, front panel, it is interface, and back panel, it is a diagram where this the code is calculated, and then you can make any procedures, mathematical or logical procedures with this data, and get output. Okay, then so you have front panel, block diagram, and some icon connector. This is a special panel, and then you are making this connection with wires, and then here, like, you put from library, you put to the front panel, you put what you want, like indicators, switches, or even you can make picture in here for better understanding. That's it. And Okay, front is for combination of controls and indicators. Indicators can be more complicated. Can be some working with oscilloscope, so it can plot. It can make some plots in time or dependence on voltage from current, etc. Quite many things can be done, and uh, then. Then you get into the panel, you also get controls. So what is output goes, so you see indicators what is the output, and this manipulating controls and indicators, you also work with this program, and then you have this block diagrams which calculate working with your signal. Sometimes it quite look complicated, but it's not, because it's actually you use a library, you use these blocks from libraries, and it is, I believe, easy to understand how to connect these signals, etc. Okay, then, automatically LabVIEW creates control indicated terminal. If you put control or indicator to the front panel, the same module creates in the block diagram, you create it automatically, and then you connect with wires to other blocks, and etc. Okay, then also if you delete it, then from block diagram, then it will be deleted on front panel also. And this what called nodes. It is some blocks which have produce execution. They can make functions. They can calculate functions. Can make some routines or loops, etc. So, and they call it node. It can be formula nodes. It can be mathematical formulas or expression. So it's up to you what to do, or just you see here it is very simple. This standard node, it is like to sum. It is the 1 plus. And you have two digital controls on the front panel, and then you use these signals to calculate something and to show at the front panel what is the indicator will be, digital indicator. So it's then you have this set of wires. You have to, when you connect these nodes, you have to connect it with special kind of wire, because there can be strings with text. So you connect with this violet wire, and with green it is boolean. It is on off, true or false, and integer numbers they have blue, and floating point numbers they have this yellow. And of course, what is good, you have array. Array is also in Golang languages. You will see it, array and strings and array. And array can be string, like string, one-dimensional, two-dimensional, and this colors different: pink, green, blue, orange. So you have to, if you connect is not connecting rightly, it will show you as a mistake. So its program works very easy to help you to write the code. I mean, to produce the code, because it is not code. It is actually a graphical language, but it works inside. It works as a compiler. So it is compiling this all this your program. It is compiling to digital binary code for computer. Okay, so you have nodes. It is different some programs executing elements, and you have terminal. Terminal, it is ports to get data. And to pass this data between the block diagram and front panel, and you have these wires, because data can be different type. Okay, then as I said, I will not go very much, very long in it, but I only say that it is a lot of fun to work with this. So you have these panels, you have these libraries, special panel, and you choose what library you will use, and if you every button here have just a lot of more libraries inside. So you click on it and you are getting more. So you can choose this or that, what to do, and also at the front panel you can choose any shape, any kind of shape or what kind of indicator or controls you can use it at the front shape. It is easy to work and fun. Okay, modifying is you work, and if you work, you have to work at front panel also, but when you put node at the front panel, the element will appear also on the block diagram. Okay, then this you see. So what kind of tools you have? You can choose a control, the switch on off. You can also editing tool and writing text and to make wires this connection between the two. You can control flow of data and different kind of indicators and probe data. So it is for to check what is in computer. You can put this probe at any place of your block diagram and to see what is happening, what data is coming out, and also some tools to design your interface to make it looking good. And so, as I said, you have a huge library for different indicators and whatever you want, some plots and or some digital indicators or it's whatever. It's quite big library. I will not go into details because again it's not the purpose of this presentation, but only to give you advice to work with this program. And I loved it, and it is so easy and a lot of fun, and it works very quick because it is compiling. It is not interpreting language, it is compiling. It is make binary code for computer, and computer works with I mean, so almost no delay. So if there is data going in, then you have control signal output or into interface with no delay. So it's really very well. Okay, examples. You can see some some stuff what people create, calculations, etc. And like voltmeter, like analog input signal, and etc. etc. Quite many different virtual instruments you can create. Okay, that's all. Just to give you an impression that there is not only computer languages based on code, on numbers and letters, but also on some digital objects, oh, pardon, graphical objects. Okay, that's all. Thank you for your time.